Welcome, everyone. Thanks for coming to the talk. My name is Omar. I'm a research scientist at Databricks. I started the DSPy project as part of my PhD at Stanford, and I've been working at Databricks for about a year, where we have a nice open source DSPy team that collaborates with the broader DSPy ecosystem. And I'm excited today to tell you all about what we've been building and DSPy 3.0, which we just open sourced earlier today. We have a lot of the DSPy contributors at Databricks and maybe even from outside in the audience, and I'll be doing a lot of shout outs to a lot of the work that they've been doing. So the context of this talk and of a lot of the DSPy work is that it's actually kind of impressive how clear it's become, how we as a AI community and data community and more broadly should train large language models and large models that do AI stuff. But as you've been hearing all around the DAIS so far and maybe elsewhere, the field is actually still guessing how to build reliable AI software. So we've managed to build this little foundation, this essentially processor for a lot of the behaviors we want to exhibit. And of course, there's a lot of improvements that are to come. But how do we actually take this and start building all kinds of applications on top that actually do the stuff that we care about? That's still unclear. And if you're here, it's because you're building with LLMs or because you work with people that build with LLMs, and the kind of name of the game is that every week a new large language model comes out, and a new interesting one comes out, not just like a copy of what was there before. Maybe it's more efficient for the quality it gives you. Maybe it's higher quality for the cost it's at. Maybe it works better in certain domains. Whatever. There's a lot of reasons you might care about those. And they don't just come out and they're interchangeable. Every time one comes out, there's new quirks. And you think that, hey, it's like next year is going to be different. And it ends up being the case that the prompting guides only get longer and longer. And that's only if you're lucky. If you're less lucky, they don't give you a prompting guide. And so you kind of just have to guess at it. And the surprising thing is that the providers, when they write these guides, they change their minds all the time. And they change their minds all the time because nobody is engineering these LLMs, right? The way they're grown, essentially, right? They're trained on a lot of data, and they emerge from just the total sum of what we trained them on. So everybody is basically interacting on the basis of a lot of trial and error, even though we have a really intuitive interface. And every month, beyond the LLMs, a new learning algorithm comes out. So nowadays is the excitement around, the well-deserved excitement around reinforcement learning. A lot of algorithms that are sort of being released all the time in open source, and that companies are building internally that you hear about that might be exactly the sort of thing that you need to finally make your app a lot better. At the same time, a lot of inference strategies, hey, agentic architectures, or inference time scaling methods, or ways of doing reasoning, or all other kinds of sort of architectural decisions are being released in research or announced from companies or announced in tutorials or elsewhere that seem to claim that they have the keys that will unlock greater reliability for your usage of large language models in building applications. And this is just everywhere. So I have here some screenshots from just OpenAI's guides on prompting. So there's a general one. There's one on 4.1. There is here is how you build agents and make them reliable. Here is how you organize your prompts, and they tell you things like, hey, you got to repeat if they have a long if you have a long inputs, you got to repeat the instruction at the top and at the bottom. They tell you things like, hey, if O3 comes out, here is how you should structure your layout for O3, which is the latest reasoning models from OpenAI. And my intention is not to pick on any particular company or anything like that. My intention is to say that when you look at all of this, you're getting lots of low-level guidance that seems to change every week, right, as these new models come out. And that was just one LLM provider. So there's actually differences across all of these LLMs. So the question that motivates a lot of what we're going to talk about is are you supposed to I don't know, stay on top of all of these just to do just to maintain the software that you're building with LLMs? And are you supposed to do that forever? I don't know. It doesn't seem particularly sustainable. It doesn't seem like the right approach. So let's actually make this concrete. Let's say that you're writing an internal productivity app in your company that every employee can use, whose job is to take their emails, maybe, and their Slack messages or Teams messages or something, and digest them for every employee to help them maybe plan their week. So maybe it's going to look at all of their emails, privately for each employee, and maybe look at all of the events that have come up that might be interesting to them, maybe things that they were invited to or things that have showed up in their email, and maybe extract all action items and things that they promised or things that they were asked to do or things that they kind of brainstormed with other folks. And then maybe kind of with this information, block some focus time blocks in their calendar so that they can work on these things, just as a, just a simple idea you might have that you want to build internally in your company. How should you do this? Well, architecturally and conceptually, it's actually a great fit for LLMs, right? You have a bunch of email threads. Maybe you take one at a time. You give the LLM the subject of the thread. You give it the email thread, all the attachments, maybe images and PDFs and whatnot. You find a way to give them to the LLM, and you just ask it, hey, give me the events and give me the action items, and I'll do some processing with those, and maybe the other processing will also do, will also call LLMs. It's incredibly simple and clear and crisp, and we can have this beautiful diagram. The problem is, you start thinking, well, what is an event exactly? It has a name, it has a location, it has a time, and in order to connect this to the rest of your system, you got to be able to actually get that stuff out of the LLM. It can't just give you a response in a chat format, right? You got to actually be able to extract this. So you start saying things like, always format your answer following this JSON schema, right? I want these little pieces in JSON format. And so far, it's actually not that harmful. You're just designing your system. And then you realize, well, I don't know. People are talking about all these prompting techniques, and the LLMs are actually fairly chatty. It works on some emails, but not others. So I'll start saying things like, hey, if you listen to all of what I said, I'll tip you $1,000. Or please take a deep breath. And I've heard that reasoning is good for LLMs. So take a deep breath and think step by step in think tags. Because then, I don't know, I hear that's supposed to make LLMs more reliable. And then you think about it, well, wait a minute. I have these complex threads. Sometimes they're long. Maybe they don't always fit in the context memory. But sometimes they also have attachments. They have all these little pieces. Some threads, have multiple emails. How should I actually feed that data? Which is, I have an object, right? I've loaded the dictionaries and the, I don't know, Python objects, let's say, or JavaScript objects. I've loaded them in memory. But now I actually got to give them to the LLM, which just expects one big blurb, right? One string. How do I serialize this into the LLM? And the problem is the way you serialize matters, right? Because if you give it in a format, it's actually kind of not ergonomic for the model. It'll do a bad job. So you start thinking about this and say, hey, people say that XML is pretty ergonomic for LLM, so I'll start doing some XML manipulation here. And then you realize, well, I have a whole bunch of emails, and even if the LLM does a reasonable job on one of them, I actually want it to be consistent, because I want to take these things and process them, and if the LLM is doing different things on different emails, it's going to be pretty hard. And you do this for a while, and then you realize it's actually still not working. So you ask around, and you hear that, hey, maybe personas are the answer. You are Professor Einstein, a PhD in information extraction from the LLM Institute of Technology. You do not hallucinate events. My job depends on it, right? So these are the types of prompts that you might see in the wild, and nobody writes this prompt up front. This always happens as a result of scars in the battle, right? Working with these models. And the problem is, you end up with a prompt that looks like this. I didn't even bother assuming that you would read it, so I just put it sideways because it wouldn't fit. And here's the issue I have. Here's the thing I'm very passionate about. Prompts are a horrible soup of a canvas for programming. They are incredibly bad canvas for programming. They're not actually that bad for management. If you have an agent who you want to treat as essentially a cheaper employee, maybe a prompt is fine. It's like having a Slack channel with a remote employee. But if your goal is to build a system that you can rely on, which has modular pieces that interact reliably with good contracts between them, right? The way we build software, prompts are a really bad abstraction for this. And the reason for that is not just they're ugly. They're pretty ugly. That's fine. It's that they entangle and mix up your actual system design, the beautiful diagram we looked at before, for example, with many tiny incidental choices you don't actually mean, but you kind of are forced to make them. And maybe you don't even really have a preference, but you're forced to make a lot of these decisions. So when you're prompting, you're hard coding, which is kind of a bad word, right? Hard coding dozens of little incidental choices like the exact wording and examples, which can be very long, that happen to appease your specific LLM. The LLM changes tomorrow. Nothing says that any of that wording was the right wording for the new LLM. The inference strategy, we said things like reasoning. It's actually a really beautiful idea, reasoning. But in practice, you're saying things like take a deep breath and write this XML, format this JSON, which is not the fundamental idea we're trying to express. how you format your data, how you specify the output format that the LLM should produce, and how you actually enforce it, and then how you actually parse, and when the LLM inevitably fails to actually follow these instructions, how you do the retries or validation or whatever it is that will allow you to handle the failures. Right? So there's a lot of code and a lot of strings, and it's still an unreliable mess. This reminds me of how we write bad code, if you want to write bad code. So I've come across this snippet on social media. It's unrelated to LLMs. I looked at this and I had no idea what it does, and I don't expect you to look at this and know what it does. But apparently it was computing a square root that was supposed to be efficient for a certain machine architecture with a certain floating point representation at some point in time. And I don't know how this computes that, but all I know is that this is clearly not the most future-proof program. For one, it's not correct the moment your floating point representation internally changes, right? Because this seems to be an ancient representation. So it's not even portable to a new hardware. But second of all, if you didn't have the name at the top, square root, right? And you're looking at this and you're supposed to maintain that code, even if you wrote it, you have no clue what this is supposed to be doing, right? And in the prompt land, that's what we get. You get this huge sort of block. You have no idea what really they are actually trying to say. I mean, yeah, sure, there's email and extract, but there's a whole lot of stuff going on here. And so you're losing track of the actual fundamental stuff. And the solution in software land, by the way, it didn't happen immediately. It took a while to get things like structured programming. People were building, all kinds of soup with, you might have heard of go-to statements considered harmful. So I'm telling you, prompts considered harmful. The solution was higher level languages that ask you to say what you actually want. I want a square root, right? And people building compilers and runtimes that take this high level expression and then figure out whatever the machine wants to hear in order to do it efficiently. And sometimes they'll do a great job, sometimes they'll do a mediocre job, but whatever it is, we're raising the level of abstraction together that we work at so that we can build actually reliable and performant software. So I think we have the same problem in prompting. Dozens of agent frameworks, I don't know why there's so many, coming out all the time. Some of them are actually helping with accessory behavior, like orchestration, validation, observability. Great stuff, actually important, almost non-negotiable perhaps. But the problem is they never tackle the central abstraction problem we've been talking about, which is that when you use any of them, still your app's primary logic is still in sloppy prompt soup. And I don't understand why this is not a problem that has been fixed at scale yet. And so we're here to tell you about the solution. And so the question that we're going to tackle concretely is, what if building AI systems was more of an engineering discipline? What if we could actually bring back programming and software engineering into the land of building AI software? Because it's not any different. So this is DSPy, a lightweight declarative framework for programming, not prompting LLMs that we've been building for the last 3 years, after another 3 years of building LLM software since 2019. What DSPy does is it handles evolving the lower level layers that we've been talking about as changing all the time for scaling, for learning, and also for plumbing. And I can tell you the plumbing is one of the hardest pieces below your app. So the first thing we do, the first foundation, is we try to turn language models from string in to string out into actual function processors, right? Because we want to build with functions that we can rely on to have a contract of input and output. And then the next thing we do is we build inference strategies that encapsulate behavior like reasoning or agents or tree search or whatever it is that's the latest interesting way of actually taking language models and turning them into the best sort of version of themselves in terms of quality. And we also handle automatic optimization, which is the question of, well, you've told us what your task is, and maybe you've also given us some data that helps us sort of understand your domain. How do we take this and actually come up with the final prompts? Or how do we take this and fine-tune your LLM weights so that you get sort of the behavior that you're anticipating? Here's what we cannot help you with, but what we make much easier. It's declaring your actual sort of AI system. So this is where you're describing the flow between all these pieces, like the diagram we saw. This is where you're describing in natural language, what are the inputs, what are the outputs, what is the transformation between them, and also where you supply evaluation sets or maybe synthesize them or otherwise define the objective that you want to climb closer a little bit to more traditional machine learning. And of course, it's entirely optional. You can do a whole lot without this one. So I'm excited to tell you that today we've open sourced the 3.0 first beta release. You can already sort of use this with pip install DSPy. And I'll tell you today about the culmination of the last 9 months of work by the DSPy open source team and contributors all around the world from all institutions, including here at Databricks. Note, barely any breaking changes. DSPy is incredibly stable in terms of the fundamental abstractions. There are 3 fundamental abstractions. They've been there basically all along, and they're still the same. But we're evolving a lot of sort of their ability and the functionality and features that we give you. So I'm incredibly grateful to over 300 contributors, many of whom are here in the audience. I would like to thank a lot of those folks, by names, Chen, Dilara, Krista, Isaac, Arnav, Tomu, Noah, Lakshya, Michael, Hannah, Corey, Hiram, Shangin, and many others. Along the way to 3.0, 2.4, we've had over 100 intermediate releases, which is just an incredible number, maybe almost absurd. Allowing the library to grow to over 1 million downloads per month and over 25,000 stars in the meantime. So let me tell you about the main concepts in DSPy, because I imagine that some of you have not used it before, although I see a lot of familiar faces, so I know some of you have been using it for 2 years. And along the way, what's new from the run-up to DSPy 3.0? So there are way too many features. I actually don't even expect you to completely grok every single one of them. My goal is just to give you a flavor, because I understand that some people here have not heard of any of this. Other people have heard of some of them. So the point is, I'll give you a flavor of those, but follow us on X, Twitter, or LinkedIn to stay sort of in touch with a lot of the detailed announcements for a lot of these things. So the first concept in DSPy, not a new concept, it's basically 3 years old at this point, is DSPy signatures, which are our way of allowing you to express how to turn the language model from string in, string out to a structured function definition, to a structured function, right? We had this nice diagram, and a DSPy signature basically is that. It's just a Python class in which you describe the task, right? The task is 1 line. It didn't need the 70-line prompt that I showed earlier. It's extract all events, if any, from the email provided. You describe the inputs, and you can actually also give them types. So you can say here, I have a subject, I have a thread, or an email thread, and I have a bunch of attachments, which is just a mapping from strings to images. Let's say these attachments are images, and I want you, the LLM, to give me a bunch of outputs. I just want a list of events, and you can define an event, maybe it's a type, maybe a pydantic type or something. And I want action items, which is just a mapping from the name of the item to just a priority, P0, P1, or P2. That is the whole thing, right? So assuming you define an event, which could be just 5 or 6 lines of I want a name, I want a title, be a similar class to this one. That is basically all you needed to describe. And here is what we didn't say anything about. We didn't specify the inference strategy. Do I want it to think step by step? Do I want this to be an agent that has tools? Do I want this to be self-reflective? Do I want this to do tree search? All of these are valid. All of these are interesting. They don't belong in your signature, because these are strategies you apply. They're not the task you want to solve. I didn't say anything about how to teach an LLM to do this. I just said what I want, right? I'm not fighting with the LLM. I'm not saying pay special attention to the attachments. I'm not saying, if you don't do this, I'll charge you $5 or something. Right? And I'm doing nothing about the plumbing. I'm not saying here is how to format an XML. Here is how I want structured outputs in JSON. This is none of the business of the signature, right? That's defining the actual behavior I want. So this is kind of a timeless abstraction that's meant to evolve, that's meant to sort of stay the same as everything else around it evolves. So for the past few months, one thing we've been doing is we've been building a whole ecosystem around these signatures that allows them to stay the same and gives you even more control if you want it. So a lot of the time, people approach us, and they're like, well, I really like DSPy. I like the way it works, but I still kind of can't adopt it if I don't know I can step in and actually change the prompts that get applied. It almost never really needs to happen, but we've exposed a whole lower layer below DSPy called adapters that are lower-level abstractions that give you the ability to control and to export out of DSPy the behavior of prompting. It's still decoupled from signatures, so you're still actually maintaining the same modularity, but we're giving you back a lot of that control. We've introduced several of these adapters built in, so you can actually swap them and see what happens if you really want to, right? But they're still kind of decoupled and general purpose. So you have chat adapters, XML adapters, JSON adapters. We've tuned those out of the box for a wide range of LLMs, and they are intelligently able to fall back to a lot of the native behaviors that come in LLMs. So a lot of the time people approach us and they're like, hey, this LLM provider, for certain types of pedantic models or something, they offer native structured outputs. It's not for everything, but does DSPy, how can I use it in DSPy? And the answer is you don't need to do anything. DSPy internally can tell, hey, this LLM provider supports this thing now. If I can't get it to work in a way that I know is effective, I'll fall back to the structured outputs in the right place and the right time. We've also universalized signatures a lot more relative to before. So right now, we've made them multimodal. You can specify input as images. You can specify audios. You can pass PDFs and PowerPoints into your signature, thanks to an extension by Maxime Rivest for just about any other type of document. We've also made sure that these things compose the way you would expect anything else in Python to compose, so you can give your LLM a list of DSPy images or a list of pedantic types. And we've also introduced a number of other advanced types that help you customize and make the best use of LLMs. The second concept in DSPy, after signatures, is modules. So those are the functionalities or the functions that can take any signature you described and then actually give it a strategy for how to actually do inference. And the nice thing is there's only a few of those. They evolve very slowly because you don't need to actually sort of adopt every minor variation. But the thing is, you take your signature, a new one comes out, you simply slot it in, and you get that new behavior for your signature. And I'll show you some examples of this. So this is the signature we had before. I didn't change it. It's the same thing. And let's say I want the LLM to reason about it, right? Some models are already reasoning models. Other models, you actually have to sort of structure them in your calls for them to reason. It is this, right? So you say, I want a chain of thought with extract events, which is the name of my signature, and I can then give it a batch of emails and say, hey, process these with 32 threads. That gives it the chain of thought behavior. There's a lot that's going to happen under this, and we'll discuss that when we talk about optimization. But it's like, hey, this is the behavior I want it to express. Oops. Let's say I want this signature to be an agent, because I want to give the event extractor, I want to give it some OCR tools to read the attachments. Maybe I want it to be able to read the attachments, turn them into text, think about them for a while. I would like an agent behavior that sort of iteratively explores things. And maybe it should be able to search other emails. Maybe the only way to understand each email is to go get a broader picture of what's going on. So I want to give it these tools. So as long as you have these two functions in Python, just two functions, OCR and search other emails, you can take the same extractor signature, unchanged entirely, and now it has become an agent. And people say, hey, Omar, how do we do multi-agents? Well, you can pass tools to an agent. Some of your tools can themselves be other agents, which is another one-liner like this, right? And you can simply pass it in the tools. So now you have a multi-agent system, right? We did not even need a new concept or a new, you did not need to learn a new thing. You simply have this highly composable, actually proper software abstraction. Let's say you hear about reflection, right? I would like the LLM to think about it, look at the output it produced, think about it again, right? And retry. And maybe it should have access to a way of assessing that, right? Maybe I have a way of saying, validating the input or something. I can give my signature to a refined method and basically a refined module and basically ask it to apply this behavior. So we've been refining, no pun intended, the reliability, productionization, and observability of modules out of the box for the last 9 months. Been aggressively working on that. With tight feedback loop here at Databricks, but from dozens of teams, including in R&D, including ourselves, in Agentbricks, especially Knowledge Assistant and the information extraction bricks, and professional services. So if you've not been to the talks by Austin and Krista, please watch them online. And if you're here tomorrow, go to Luis Moros's talk on how he's using DSPy as part of his data science work and professional services work at Databricks. We work also with a lot of Databricks customers. I have a number of Databricks customers here that are sort of okay about going public about their DSPy usage, although there's a lot more that we didn't get to ask. And the rest of the DSPy developer community and sort of user community, which is pretty large. We have a nice Discord if you sort of want to be part of that. You've probably heard today in the keynote the announcement of the Agentbricks. This includes a lot of Mosaic magic and tools, but it also includes plenty of DSPy magic in there, especially in the two I mentioned earlier, Knowledge Assistant and information extraction. And having discussed modules, let me tell you all about sort of what's new in them. We've been working on better scalability. So we've been really focused on sort of making sure you can productionize these things at really large scale. So we can now batch process with your modules. Thread safe out of the box. It does a lot of heavy lifting for you. DSPy is now natively async. We have a high concurrency cache built in by default, but it's incredibly customizable. And we've been working on a much smaller package size. We've been also investing in the developer experience. So you can do streaming of structured outputs in DSPy. You can get usage tracking and all kinds of granularities of the per language model globally for a single program, for a part of a single program. And you can get and track history of each part of the DSPy system that you have as well. And for deployment, we've been working closely with the MLflow team, so closely, in fact, that we share some of the same people to make sure that saving and loading in Databricks and exporting the prompt management layer and things like all kinds of deployment concerns, like getting all the versions and whatnot, is handled very smoothly. We've revamped the entire docs while working on all of this, and we've been working on integrations along the way for interacting with tools from LangChain or MCP servers out of the box. We've been improving how DSPy allows LLMs to execute code, because we think a lot of the future is going to be LLMs generating and executing code as part of their thinking processes. And we've been building modules precisely for this. If you were at Chen's talk earlier today, you would have heard that MLflow 3.0 includes a lot of native integrations with DSPy that allow you to see the prompts, allow you to see the optimization processes, and see how the gains are ongoing, and allows you to also kind of track all of the systems that you've saved. We've also heard a lot of requests for courses, and so we did a nice collaboration with Andrew Yang's deeplearning.ai team and announced last week that there is a nice short course on DSPy, maybe the first of some to come, and we're interested in your feedback. It's a great learning resource, thanks to Chen from the team. And now, finally, the section that many of you are probably looking forward to. So the third concept in DSPy, and the one that is we're often quite known for, is DSPy Optimizers. These are the components that you give, say, your program. Could be a single prompt program, could be a really complicated agent, and you give it a metric, what is this thing supposed to do and do well, and maybe you give it a bunch of inputs, like some questions that people have asked, and it figures out how to prompt your LLM, or even if you have an LLM that supports fine-tuning APIs, how to actually update the weights of the LLM to fit your task. So we've seen, the optimizer that's been around in DSPy for the past year and is most popular is called MIPRO. We've seen hundreds, maybe even thousands, really, of MIPRO runs and use cases over the past year, and we've used that to refine a lot of the little details that matter for reliability of MIPRO. We've also automated its configuration out of the box. We used to hear, hey, I don't know how to configure this parameter or that parameter. So right now, this code here is a complete piece of code, not only to use MIPRO, which is this 2 lines, right? It does not require any hyperparameters. You just give it the judge, you ask it to compile your extractor program that we defined earlier. But it also here has the ability that, I'm here defining a judge, which is GPT 4.1, that's going to teach my Llama 1 billion parameter model how to be as accurate as possible for this task. And this is actually a complete piece of code in terms of that functionality. A related, similar task of information extraction that I worked with, and this is actually, it's a little public snippet I posted a while back, actually allows the model to learn to jump in performance, basically doubles the quality of the small model. And this is, something that you can do quite often. So thanks to a lot of the team's work on this and the reliability of MIPRO, at LlamaCon a couple of months ago, Meta announced a new prompt management tool and migration tool that they use to allow people to move off of other models to the latest Llama models. And lo and behold, at the core of it, it was built in DSPy and relies on MIPRO and delivers up to 14% gains on their RAG customer evaluation. The same day, I don't know how these things happen, Amazon AWS also announced a migration tool based on MIPRO, but this time only 13% gains on summarization evals. Columbia researchers and researchers everywhere are using these things and sort of writing about them in public. So Columbia researchers announced Papillon a while back, which is a privacy-oriented system for coordinating large and small LLMs. And they used MIPRO out of the box. I know because I was slightly involved. And it improved the quality of the systems by up to 41% and decreased leakage of these small LLMs leaking information to large models by up to 68%. Physicians at the data lab significantly improved the quality for chest X-ray and head CT reporting by over 10%, comparing with other approaches for prompting, and then outperforming all of those thanks to MIPRO. And so many other instances. I just really didn't have the time to cover even a small fraction of these, but a lot of them are public, and a lot of them you can find on our accounts on social media or our Discord. People like to post the stuff there. But to get a lot of this in the same place, we collaborated with folks at UC Berkeley, Shengi Tan and Lakshya Agrawal, to build this Lang probe, language model program benchmark, that basically brings together a lot of the types of AI software that people build and defines them in DSPy, and then runs a whole suite of LLMs with a whole suite of optimizers, with a whole suite of the types of different programs on a bunch of different data sets and tasks, so that we get a sense of where we stand and what matters and how well do different things perform. I don't have the time to actually explain the whole figure, but a short idea here is that the program you build really matters, but at the level of the structure of the system design, not the little prompting techniques. And then applying an optimizer on top gives you, that final, really important sometimes cherry on top. And in their evaluation, MIPRO was the best optimizer in their comparisons on average. But moving beyond MIPRO, which has been great, we've been developing the next generation of DSPy optimizers for a while. And we've been thinking about it really hard for quite some time. And so for the past few weeks, and this is something you can bet on, we always do this, we've quietly released, and we've been evolving, the next prompt optimizer. It's been there, called DSPy.SIMBA for the DSPy power users, which are whoever just, we have a lot of those folks, just find it, they look at the release notes, or they just look at the new directories, and they start using it, and they start complaining, or they start giving us feedback. And it's a really helpful way for us when we stand today to tell you, hey, you can use this thing. It's been being used for a while. It's a great way we do betas, but in the open source community. Right? It's based on extensive exploration from Krista, Michael, Ryan, Hiram, and Arnav. So what is new about SIMBA? One of the key fundamental things that are new here is that we want to highlight using reasoning to do the actual learning or to do the actual optimization. And we found that this can be really essential for tasks that have a lot of steps, long horizon tasks. A lot of people call this agentic tasks. The way SIMBA works is well beyond the scope of today, but I still wanted to give you a flavor, I promised, right? So the way this is going to work is it takes your data set, it samples a mini batch, like a bunch of examples, and it takes your program, and it runs each example through your program a bunch of times, maybe 6 times. And then it looks at those runs, these rollouts, which is very similar to how certain reinforcement learning algorithms work. It looks at those, and then it finds which examples had essentially high variance, right? Which examples had the largest spread between runs that really worked and the ones that really didn't. And the reason it looks for those is that essentially they're going to teach us a lot. They're going to have, there's some behavior that you do that's unreliable, but that could actually really help. And then it looks at those, and it runs certain strategies for learning, whose job is basically, essentially, to ask an LLM, hey, it worked here, but failed there. You can see exactly what happened. Can you tell me what I should do in the future so that I get more of the behavior that works, right? How do I kind of amplify the behavior that works? And there's various ways of doing this that we've been exploring and adding to SIMBA. How do I use SIMBA? It's complicated. Maybe you don't really care how it works. It's just the same 2 lines. You switch MIPRO, you replace it with SIMBA, and that's the whole point of DSPy. It's like, man, we're really proud of you, MIPRO, but it's probably time to move on. How do you move on? You just change the name of the optimizer, right? And then you have the latest and greatest of the optimizers. Another really cool thing about SIMBA is that we've really gotten a lot of feedback of people where they're like, my metric is giving the optimizer a score of 0, but I actually know why it was wrong. I wish I could tell it. So we allow you in SIMBA to actually return feedback that tells the optimizer, yeah, this thing is getting 0, but the reason it's getting 0 is that in step 5, it called that tool and it's not supposed to, or something like that, right? You have a judge or an automatic way of detecting that. The optimizer can actually look at this and leverage it in its reasoning. So on the tool hop task, which is a task where basically you wake up in the LLM agent, you're given a bunch of tools and you're given a goal, and your job is to basically call these tools until you have the answer for the question. So a simple GPT 4.1 agent on this task gets 47%. You simply apply SIMBA on it out of the box, and you jump to 70%. And there's a nice, interesting kind of prompt here. I simplified it to fit in the slide and generalize it slightly. It says things like, hey, if you attempt to use a tool that raises an error, do not give up, right? Do not simply assume it failed. Instead, here is how you should try alternative things. If all of the programmatic attempts fail, well, sometimes a lot of these questions are about popular items, that you might already know in your internal knowledge. So, maybe try to leverage that and see if it gets you any closer. That's the prompt that it teaches itself, right? Maybe you have a different task, but it will learn something very different. Indeed, SIMBA has been picked up by power users, even though it's not really something we've sort of officially kind of publicly announced. So Mike Taylor, author of the book Prompt Engineering for Generative AI by O'Reilly, recently published a case study at his company, Ask Rally, for using SIMBA for user simulation studies. It was the best performing out of the DSPy optimizers he worked with, all of them being way better than the baseline. And this was the prompt it learned, or part of the prompt it learned. It's actually very interesting, but obviously I'll let you kind of find it online maybe and look at it. We've also been seeing a lot of the same in anonymized R&D results we have here at Databricks, where SIMBA is clearly up and coming in terms of being an improvement on average across, relative to MIPRO, but it's still evolving. So kind of close to wrapping up, I told you optimizers can optimize your prompts, but one of the things we're most excited about in 3.0 is that we're doubling down on being able to optimize your weights. We've always been able to do it, but it's always been kind of a more peripheral thing. We've been investing a lot to make it incredibly reliable. If you have a local language model, or if you're working with a remote LLM that has fine-tuning APIs, like OpenAI, for example, or Databricks model training, how do we actually get fine-tuning to sort of be applicable in your programs? And so everybody is super excited nowadays about reinforcement learning. There's no reason why, if you wrote the beautiful DSPy programs, that you can't apply reinforcement learning on top of them without changing them. There is no reason you couldn't. That's always been the case. But now you actually can, because we built this sister library, Arbor, led by Noah Zimes at Notre Dame, Dilara Soilu at Stanford, and Lakshya at Berkeley, which allows you to do reinforcement learning over DSPy programs. How does it look? You probably guessed it by now. It is simply you swap MIPRO and SIMBA with DSPy.grpo, which is the name of the specific reinforcement learning algorithm that's actually behind a lot of the LLMs being trained nowadays. But we've generalized it to allow it to fit any agent and any system you've built in DSPy, and you give it the same metric you usually give to a DSPy optimizer. You give it the same inputs you give it to a DSPy optimizer, and if your LLM supports working with Arbor for reinforcement learning, you get a reinforced version of your system or agent. And I don't want to spoil kind of the details, so I've anonymized a lot of these results and kind of just we've taken them without the task names, but it's very promising, and in some cases it can be quite a bit better than prompt optimization, although it's a lot more expensive. Other times we find that actually composing the two, so allowing DSPy to do prompt optimization and then doing reinforcement learning, is exactly what you need to do. And so we're excited to tell you all about these in subsequent releases that the team is excited about. So very quick recap, and to wrap up with this, pip install the 3.0 release. You can already do that today. Some of the major things is we've been working on a mature ecosystem of adapters and base types that give you a lot of control, really full control and extensibility. We've been working on multimodality, making signatures the universal interface to LLMs. And we've been making sure that modules are as robust, easy to productionize, observable, with a lot of native integrations with MLflow 3.0 very, very tightly. So we've automated a lot of the stuff that made MIPRO slightly harder to use in the past. It's basically just, you just call it at this point. And we've released 2 really powerful optimizers, the future of DSPy prompt optimizers, and then we're investing very heavily as an open source community in the reinforcement learning direction for whenever you're using open models or models that you want to fine tune. And stay tuned for a few really key updates that are coming in 3.1 and 3.2 that sort of didn't really make it in 3.0, but we're very, very excited about those. So I'll leave you here with the closing slide. I don't know how I finished on time. I'm sorry, this was really fast. But if you leave with one idea, it's that, hey, Prompts are soup. They're not really a good canvas for programming. We've been thinking for 3 years about how to actually sort of give you an abstraction that allows us to actually turn back to engineering for these types of systems, and that's backed up by 3 earlier years before that of building LLM systems from the days of BERT. DSPy fundamentally, in terms of the signature abstraction, has stayed the same since Text Da Vinci 2, if you remember what that was, up to 04 or 04 mini nowadays. And the reason for this is that we're building abstractions around the fundamental ideas of programming, like functions and the types that allow function contracts to be defined instead of like the latest fad or something. And that allows you to get really powerful ideas like multi-agents as simple compositions of the 3 or 4 tools that we give you that are highly interchangeable. Thank you all very much. I'll stick around for people that have any questions or discussions. Thank you.